Hello students, in this video we are starting a new concept, three-dimensional coordinate geometry. This is new for all of you because the first time it is introduced in class 11. So in this geometry we discuss about the space, three-dimensional geometry. So if we want to plot any point in space, so what are the necessary things in which we can plot the point? So if we want to plot any point in space, we need three mutually perpendicular axes known as x-axis, y-axis and z-axis. There are three mutually perpendicular axes, x-axis, y-axis and z-axis. All the three axes meet at a point O and whose coordinates is always 0, 0, 0. Coordinate of any point in space can be written as x, y. This way of writing is called triplet form. Just like when we use the coordinate geometry to dimension, the coordinates written in the form of ordered pair form. Similarly, in coordinate geometry 3 dimension, the coordinate of any point written as x, y, z, and this way of writing is called triplet form. Okay? Suppose that there is a point P in space and we want to reach this point. So how can we do? First we move, and suppose the coordinate of the point P is x, y, z in space. So first we move the distance x in the direction of x. After it we move distance y in the direction of y, and after it we move distance z in the direction of z-axis. So this is the way for reaching the point P in three-dimensional coordinate geometry. There are three mutually perpendicular axes. Mutually perpendicular axis. These axes divide whole space into 8 parts. Just like as in coordinate geometry 2 dimension, the two mutually perpendicular axes known as x-axis and y-axis divide the whole plane in 4 parts, and this part is called quadrant. Similarly, here these three mutually perpendicular axes divide the whole plane into 8 parts, and each part is called octant. Each part is called octant. Now we discuss about the sign convention in each quadrant. Just like as in coordinate geometry 2 dimension, the coordinate of any point, if any point lies in first quadrant, then the sign of the coordinate becomes positive, in second quadrant minus positive, in third quadrant minus, and fourth quadrant positive minus. Similarly, what are the sign convention in all the octants? Now octant and sign. First obtain x, y, z. If all the signs are positive, x, y, z dash, that means x and y become positive but z become negative. X, y dash, z, positive minus positive. X dash, y dash, minus plus plus. Now x dash, y dash, z, minus minus plus. X, y, x dash, y, z dash, plus minus plus, and finally x dash, y dash, z dash, minus minus minus. 1, 2, 3, 4, 5, 6, 7. One is that. One is that. X, y, z dash, x, y dash, z, x dash, y dash, z. Now x dash, y dash, z, x dash, y, z dash. One more, sorry. X, y dash, z dash. That means plus minus minus. Finally x dash, y dash, z dash. This is minus minus minus. So this is the sign convention. If any point lie in first octet, that means x, y, z. This is known as plus plus plus. If in x, y, z dash, plus plus minus. So this is the way of sign convention in the quadrant. In the octet, point lies. Coordinate of a point. Whenever we discuss inside the coordinate geometry 3 dimension, there are three mutually perpendicular axes. One is x, second is 1, and third is z. So if we want to take coordinate of any point, how can we select them? First, coordinate of any point at x-axis, x, 0, 0. Coordinate of any point at y-axis, 0, y, 0. Coordinate of any axis of any point, at z-axis, 0, 0, x. So if you want to take any point on x-axis, we take the coordinate of this point as x, 0, 0, because at x-axis y and z become 0. If coordinate point lies on y-axis, then we can take coordinate of the point 0, y, 0. And if you want to take coordinate at any point in z-axis, so we can take the coordinate 0, 0, z. Now we will discuss about the coordinate planes. Coordinate planes. Coordinate planes. What is the concept of coordinate planes? Suppose that we are discussing coordinate geometry 3 dimension inside the classroom. So we choose one corner of the classroom and take the core point of the corner as the origin, one edge of the wall as the x-axis, another edge of the floor as y-axis, and the edge which is touched to the roof of the room take as the z-axis. So in this room we take the x-axis, y-axis, and z-axis. Okay, so we discuss about the coordinate plane. First, plane joined by x-axis and y-axis, known as xy plane or xoy plane. Similarly, plane joined plane, xz plane or xoz plane. The plane which can be obtained by joining x and y axis. Okay. Similarly, plane formed by y axis and z axis known as yz plane or yuz plane. So these are the three coordinate planes: x, y plane joined formed by using the x and y axis, xz plane formed by the joining x and z axis, yz plane which formed by the joining y and z axis. Any point coordinate of any point in x y plane. Suppose that we want to select a point in x y plane will be x comma y comma 0. Coordinate of any point in xz plane, x comma 0 comma z. Coordinate of any point in yz plane, 0 y z. So this is the way of selecting the coordinates of the points which are taken in xy plane, yz plane or xz plane. Now we discuss about the distance between 2 points in 3-dimensional coordinate geometry. Let P, whose coordinates are x1, y1, z1 and 2, x2, y2, z2 are 2 points in a space in which we want to find distance between P and Q. Formula is that PQ equal to x1 minus x2 whole square, y1 minus y2 whole square, z1 minus z2 whole square, or this can also be written as P equal to PQ equal to. There is no difference if we use this type y2 minus y1 and z2 minus z1. So if the coordinates of 2 points are given, we can find the distance between 2 points using this formula. Suppose that P x y z be any point in space. If all the 3 parts of the triplet x, y, z are non-zero, this shows that the point confirmly lies in space. If any one part of the triplet is 0, that means our point lies in any coordinate planes. If 2 parts of the triplet is 0, then we can say that point lies on the x-axis, y-axis or z-axis. Here that P x y z is any point in space, then distance of P x y z from x y plane, this is equal to z. This is equal to z. Whenever you want to find the value of Find the distance between the point P from the xy plane. So you take any point on the xy plane and whose coordinate will be x, y, 0. So the coordinate also can also find the distance, but directly if P x y get any point in the space, the distance from the y will become z. Distance of P x y z from yz plane, this become x, and distance of P x y z from xz plane is equal to y. Suppose that P is any point in space, and this is the point in xy plane. This is x, y, and z. So we take point n, and in xy plane, the coordinate of n become x, y, 0. Now apply the formula. You have square root of x minus x square, y minus y square, z minus 0 square, that is equal to. This is the way how to find the distance of a point in space from the yz plane, xy plane, and z plane. Now similarly, if you want to find the distance of the point in space from x-axis, next point, point number 8, distance of P. Distance of P x, y, z from x-axis. From x-axis, this becomes square root of y square plus z square. Distance of P x, y, z from y-axis. This is under root x square plus z square. Distance of P x, y, z from z-axis equal to under root of x square plus y square. So these are the distances for any point in space from the planes or from the